Okay, Chapter 20, Cost, Volume, Profit Analysis. This is a real fun chapter. I like this chapter, and quite frankly, it's a pretty important chapter, hopefully one that'll stick with you for hopefully all your career, whatever that career might be. This is not, again, this is not just for accountants. This is for anybody going into business. Again, this is the language of business, accounting is. So, and this ties into financial accounting. It's kind of hard to divorce managerial accounting totally from financial accounting. And again, this is true here. Okay. All right. So cost, volume, profit analysis, aka CVP analysis, is used for many types of decisions, many types of questions that need to be answered. And so some of those might be, how much must I sell to earn my desired income? And there, the number of units could be involved. You could translate that into dollars as well. How will income be affected if I reduce selling prices to increase sales volume? What will happen to profitability if I expand capacity? And there are many other questions that this can answer. How much will it take? How much revenues will it take to break even? All right, so some of the preliminaries before we get into answering some of those questions are the following. Understand that a cost has a behavior. And I know that you're going, well, I thought only humans had behaviors. I guess animals do too. But they talk about costs in the context of a behavior. And so for the most part, costs are really one of three things. They're either fixed. A fixed cost is any cost that remains constant regardless of activity within a relevant range. Well, what would that be? Here they use monthly basic telephone bill. I guess if you have a landline, this may be still accurate. Let's get more sophisticated with our example and talk about a warehouse or a manufacturing warehouse. That manufacturing warehouse that you're paying for each month costs you $10,000 a month. Regardless of what your output is, regardless of what your revenues are, how many goods you produce and sell, you've still got that cost of $10,000 to pay for that warehouse. And that's true whether you produce 0 or 1,000,000 of whatever it is you produce. Now, again, I said within a relevant range. Well, what if you only have capacity in your warehouse for 1,000,000 units? If you wanted to produce 2,000,000, you'd have to expand the facility. Well, that's that relevant range. So within the relevant range, whatever that is, whatever capacity this cost will hold, in this case the warehouse, that's the cost. $10,000 a month. Now, the other type of cost you can have, well, we'll get to that in a minute. Note that the cost per unit the cost goes down as a per unit cost. So you're paying $10,000 a month and you make 10,000 units. Well, the fixed cost per unit is exactly $1 per unit. Well, let's say you increase your output to 20,000. Your fixed cost remains the same, total fixed cost, but your fixed cost per unit has now been reduced to 50 cents per unit. So notice that the cost per unit, here it's cost per call, declines as activity increases. All right, now compare that with variable expenses. These are costs that increase as activity increases. Well, you've got that warehouse that you've got to pay for regardless of activity, but once you put the manufacturing in process, you're going to have cost of raw materials. Your raw materials cost is going to increase as activity increases. Your direct labor is going to increase as activity increases, and factory overhead is going to increase as activity increases. So again, they've got a little graph here. As activity increases, here the activity is minutes talked. As the activity increases, the variable costs increase. Now note, within a relevant range, the cost per unit the variable cost per unit will be constant within a relevant range. Another kind of cost is called a semi-variable cost, and if you have a landline, that's at least back in the old days that I remember. I don't have a landline anymore and haven't for probably 10 years. But here's an example. It contains both a fixed portion as well as a variable portion. Okay, and the fixed portion is incurred regardless of how much use there is. If there's zero use, there's still a charge of the fixed cost. And the variable portion is, in this case, for a I guess this is electric utility charge. Haven't paid that in a while either, but anyway, here the variable charge per kilowatt hour used goes up as more kilowatts are used. So you got that fixed service fee and then a variable charge per kilowatt hour used. Now notice we've got a graph here starting, and on one side of the graph you got total utility cost, and at the bottom of the graph you've got your activity. So Costs are always going to be on the left-hand side. Activity is going to be on the bottom. And you've got, in this case, a fixed monthly utility charge as well as the variable charge. And again, this is just simply a graph that represents these CVP relationships. And so what you have there in the green line is the total revenue line with a slope equal to the unit sales price. So notice you've got volume in units at the bottom. Along the left-hand side going up, you've got costs and revenue in dollars. Okay? So you've got the green line starting at 0, meaning at the very bottom you've got 0 income. As you go up, your revenue increases. The red line is your fixed cost. It extends horizontally. And then you have the variable costs. It starts at the fixed cost and goes up as activity, the number of units, increases. And note that there's a junction of the green line and the blue line called our break-even point. This is the point where neither profit or loss is made by the company. Anything below the blue line is loss. Anything above the blue line is profit. All right, so this is just a summary of what we've talked about. Variable costs per unit remain the same even as activity level changes. Now, of course, that's within a relevant range also. As far as fixed costs per unit, they decrease as activity level increases. Back to variable costs, the total for variable cost changes as activity level changes. For fixed costs, the total cost remains the same regardless of activity, again, within a relevant range. Here they talk about economies of scale. I don't really harp on this too much, but what they're pointing out here is that companies that have a high fixed cost can leverage those assets to make more things, okay? And so, because why? Well, the fixed cost per unit goes down over time. The higher the activity, I guess I should say. And so they have an example here of an automobile plant, fixed cost per month, $8,400,000. Well, they're going to have to pay that regardless, right? And so it behooves them to make more product because their fixed cost per unit goes down. Again, within a relevant range, obviously, there has to be demand there, because if there's not demand, it's just these items that they make are just going to sit and grow dust. So just realize that. All right, we're not really going to talk about these other types of costs. What I want to get to is this thing called break-even point. The break-even point, like I said, is the sales level where the company earns neither a profit or loss. Okay? Well, if you look at page 868, you note a formula there: revenue minus fixed cost revenue minus variable cost. You don't know this yet, but revenue minus variable cost equals this thing called gross profit. You may have dealt with that before. And then gross profit minus fixed costs equals operating income. So I put in an extra step there from their little formula. And usually, rather than go left to right, it's best to go down, bottom to top. Revenue minus variable cost equals gross profit. Gross profit minus fixed cost equals operating income. All right. So, bottom line is the break-even point there is where you have zero operating income. Your variable costs and fixed costs plus fixed costs are the same as revenue. This is what they're saying there, because at that point they have neither operating income or operating loss. Oh, I misspoke. I said gross profit. I meant contribution margin. So sales revenue less variable costs equals contribution margin, not gross profit, less fixed costs equals operating income. So you've got an example here of a company that sells 900 units at $90 per unit. So that is $81,000. If variable cost per unit is $36 per unit, and they've sold 900 units, their variable costs are $36 times 900 units, or $32,400. And so 81,000 minus 32,400 equals 48,600. And then fixed cost will usually be a given, but not always. And so to define contribution margin, it's the amount by which revenue exceeds the variable cost of producing the revenue. All right, so how many units must the company sell to cover its fixed costs to break even? Well, that would be where contribution margin is the same as fixed cost. So we've got to figure out how many units to sell to have a contribution margin of exactly 37,800, because at that point, contribution margin of 37,800 less fixed cost of 37,800 equals 0 operating income, thus break even. So you could do that a couple of different ways. You could take as they did, the 37,800 divided by the $54 per unit, that's your contribution margin per unit. And what you come up with is 700 units that you need to sell to break even. And so 700 times the $90 per unit means that they would need sales revenue of $63,000. 63,000 less 700 times 36, what is that? $25,200 would be your variable costs. So 63,000 minus that would be 37,800 contribution margin, and so that's going to put you at your break-even point. Okay? So one of the questions we mentioned that we could answer with this CVP analysis is how many units must we sell to break even? And that's kind of what we just did. So break-even point in units equals, as your numerator, the fixed costs. That's 37,800 in our example. The denominator is the contribution margin per unit. Well, what's the contribution margin per unit? Well, it's the unit sales price less unit variable cost. And in our example, 90 minus 36 equals $54 contribution margin per unit. So that's where we came up with the 700 units. All right, so we have an example here. ABC company sells product XYZ at $5 per unit. If fixed costs are $200,000 and variable costs are $3 per unit, how many units must be sold to break even? Well, let's see. They sell product at $5 per unit. They have a variable cost of $3 per unit. So contribution margin per unit is what? $3 per unit. So here, what you're going to do is you're going to take and you're going to divide the 200,000 contribution margin, fixed cost, and divide it into your contribution margin per unit, which is $2. The 5 per unit that they sell it at minus the variable cost per unit of 2. So they must sell how many units? 100,000 units. Another question, how many dollars in sales must we generate in order to break even? So break-even point in dollars in the formula is fixed costs minus contribution margin ratio Well, what's the contribution margin ratio? Well, got a new thing here. To figure out the contribution margin ratio, you take the unit contribution margin, which in our example was what? $2, and you divide that into unit sales price, right? And so 37,800 divided into 60% equals $63,000. The other way to do this is, well, here it was what, 50, I take it back. Unit contribution margin was 54 and unit sales price was 90. So that's where you come up with that 60%. And then you divide that into the 37,800 to come up with your 63,000. There's a couple of different ways of doing this. Use the contribution margin ratio formula to determine the amount of sales revenue ABC must have to break even. All information remains unchanged. Fixed costs are 200,000, unit sales price is $5 per unit, and unit variable cost is $3. So we kind of already figured this out, right? So your unit contribution is $2. Your contribution margin ratio is 0.40. Break-even revenue equals the $200,000 of fixed cost divided into the contribution margin ratio of 0.40. And so your answer is $500,000. You can also take and determine how much sales are needed to achieve a target income. You can do this in units as well as dollar amount of sales. And so here you're just simply adding this target income in your numerator. And so to determine your needed income for a certain target level of operating income, in unit sales, you simply add fixed cost plus target income in the numerator and divide by contribution margin per unit. For dollar sales, same numerator, you simply have as your denominator the contribution margin ratio. And so here, this company wants to earn a $5,400 monthly operating income, so they take their fixed cost of $37,800, add the $5,400, and divide that into your contribution margin per unit to come up with 800 units per month. Same thing at the bottom. What they have to figure out is dollar sales, not unit sales. You simply take your fixed cost plus target income, $37,800 plus the $5,400, and divide that into the contribution margin per margin ratio, not per unit, of 60% to come up with 72,000 per month. And again, if your contribution margin is, if your revenue is 72,000 and your variable costs are, 800 times, I believe, 36? So anyway, ABC company sells product XYZ at $5 per unit. If fixed costs are $200,000 and variable costs are $3 per unit, how many units must be sold to earn operating income of $40,000? Again, you would take the $200,000 and add 40,000, so that's your numerator, 240,000, and divide it into what? Well, your contribution margin per unit is at $2 per unit. And so 240 divided into $2 per unit is 120,000 units. Margin of safety, not really all that big of a deal. It's simply the amount over which actual sales is in excess of break-even sales. So if break even's 10,000 and you're at actual sales at 12,000, you have a margin of safety of $2,000. Now you could do that again. Per unit or dollar amount. And so as they indicate here, margin of safety provides a quick means of estimating operating income at any level of sales. So here we've got this company, 72,000 actual sales minus 63,000. They have a $9,000 margin of safety. And you can turn that around, manipulate this to figure out your operating income is what they're essentially saying. So operating income equals margin of safety, $9,000, times the contribution margin ratio, which is the 60%, 0.60, or $5,400 operating income. Another way of looking at break even is that any dollar of contribution margin becomes operating income that's in excess of the break even. And so again, change in operating income equals change in sales volume times the contribution margin ratio. So in this example, Snowglide expects sales to increase by $5,000 and has a contribution margin of 60%. How much will operating income increase? Simply take the increase in sales and multiply that times the contribution margin ratio, and in this example you come up with an increase in operating income of $3,000. So here's a common type of financial statement for managers looking at numbers. You got your sales there. You've got the total number of units of 900. You've got your total revenues of 81,000, which means that per unit sales were $90 per unit. You've got your variable expenses that you're deducting from that, 32,400. So per unit, variable expenses are, you take the 32,400 and divide it into 900 boards to come up with variable cost per unit of $36. And then what's left over is your contribution margin. 81,000 minus 32,400 is a contribution margin in dollars of 48,600. In the per unit column, it's $90 per unit minus $36 variable expenses per unit. And so your contribution margin per unit is $54. And then over to the right, you've got your percentages. Sales is always going to be 100%. And then whatever variable expenses are of that total, 32,400 is 40% of 81,000. 36 is 40% of $90. And so what you're left with is a contribution margin per unit of $60. And then you've got your fixed expenses there in the total column that you're reducing contribution margin by to come up with operating income. So this is a fairly common statement that you'll see managerial accountants use and that managers use in order to make decisions. So the question here is, should Snowglide spend $1,500 on advertising to increase sales by 500 boards? Well, if they do that, they're assuming that they're not changing any per unit numbers, that they're going to sell at the same price per unit, and that variable expenses will still be $36 per unit. Remember that, that doesn't change within a variable range, but you produce enough of these things, then variable costs might actually increase per unit. Why? Because you might have to bring in workers that you don't have, so you might have to increase your labor staff, things like that. The raw materials might become more expensive, all kinds of things. All right, so notice the per unit column doesn't change. The percent column doesn't change. So they're making some assumptions here is what they're doing. That's a big part of this, is that you have to make certain assumptions that you can still sell 1,400 boards at $90 per unit. And so they simply run the numbers. 1,400 boards times $90 per unit equals 126,000. 14 boards at 36 per unit equals variable expenses of 50,400. So your contribution margin is the 1,400 at 54, or 75,600. Now notice your fixed expenses has increased. Why? Well, because you've added more advertising of 1,500. It was 37.8, now it's 39.3. And so operating income in this assumption is now 36,300. Snowglide's plant manager does not completely agree with the advertising director's projections to cope with the increased demand. He asserts that many factory workers will be required to work excessive overtime hours, causing an increase in direct labor costs of approximately $180 per unit. That's where assumptions can go wrong. Assuming he is correct, he wants to know the sales volume in units required to achieve the advertising director's projected income figure of 36,300. Okay, so here we're taking the selling price. The new unit contribution margin is figured out by taking the selling price and the new unit variable cost. In this case, the $36 per unit cost plus the $180 per unit cost in additional labor. And so the new unit contribution margin in this case is $90 minus $37.80, the original $36 unit variable cost plus the $180 additional for additional labor. And so new unit contribution margin is $52.20. And so you can take that number and figure out your unit sales. And so you've got your fixed cost of $39,300. That's the original fixed cost plus the $1,500. And to that you're going to add the 36,300. Again, that's in the example. He wants to know the sales volume in units required to achieve the advertising director's projected monthly income figure of 36,300. So that's the target operating income. And you're going to divide that into this new unit contribution margin of 5220. What you come up with is 1,448 units. Here, the Vice President of Sales thinks that a more conservative increase of 350 units per month is likely with the extra overtime. Based on this, how much would Snowglide have to raise selling prices to achieve a target monthly income of 36,300? And so we're going to take, to figure out our projected unit sales, we're going to have to take, again, as our numerator, fixed cost plus target operating income. That's our 39,300 plus 36,300. What we have to figure out is our contribution margin per unit. And so we take our unit selling price Let's see what they're doing here. Oh, okay. So 350 units per month likely. Add that to the 900 units that they originally sold. That's your 1,250 units. And you would take the 39,300 plus let me make sure I get this right. Plus 36,300. Yeah. What you would do is, in this example, take the number of units that they assume that they can sell, 1,250. You've got your fixed cost of 39,300 plus the target operating income of 36,300. You're going to divide those numbers, 75,600, into the 1,250 units to come up with contribution margin per unit of $60.48. And if that's your unit contribution margin, you know that it's $60.48. You know that unit variable cost is $37.80. And so you can add those two together to come up with unit selling price of $98.28. Wasn't sure what they were doing there at the very beginning. Additional considerations in CVP. First, different products have different contribution margins. So, I mean, you might have to have several different analyses for different types of products. You have to break those out. There might be some semi-variable cost elements involved. And again, the assumptions. Sometimes the assumptions you need to change because of whatever reason, as we saw. Fixed costs are not going to necessarily remain the same. Variable costs per unit might not remain the same because, again, you might need to add additional labor or something like that. And that's really all I wanted to talk about in this chapter. You can do this on a multiple products from a multiple product standpoint. You can do a CVP analysis as well, but I'm not too interested in getting into that because I think you've kind of had enough as it is. But if you want to look at that, that's fine.